Hi, my name is Andy Scree, and today we're going to talk about operationalizing Exabeam. How can we leverage Exabeam in the advanced analytics solution to help us investigate malware that's found within the organization? So for most companies, if they're just using Exabeam to investigate the notable users, they're missing out on a lot of the benefits that the advanced analytics product can offer. So today we're going to focus on malware. In most cases, malware detections are happening hundreds or thousands of times every single day. And most of the time, we're not investigating every single piece of malware that happens. If it was detected and cleaned, we kind of move on and look for something that maybe wasn't cleaned. We're not doing full investigations to better understand where did the malware come from, what did it do once it was installed on the machine. So today we're going to use the analytics to help understand more of these questions and how do we better understand the malware that's in the organization and how it might impact the risk to our business. So what we're going to do is we're going to look at the advanced analytics and we're going to start using Threat Hunter to first uncover the pieces of malware that have been found within the organization. So what we can do is we can start very broadly. We're going to open up our Threat Hunter capability. Now in Exabeam, a malware detection is considered a security alert. So we're going to simply come through here and we're going to expand our dates. And I'm going to look all the way since January of this year. And we're going to look for security alerts. I'm going to select my activity type here as security alert. Now, this is going to return any security alerts that have been found within the analytics. Now, this is going to include DLP and AV in my particular environment here. So now that I have all of my security alerts returned, I can see I have 8 total sessions that had security alerts. Now, I may want to start from here and just start to look at the riskiest sessions. Right? So here, this is already helping me understand that there was some malware or security alert found, and because the risk score is very high, there were other activities that led to an increase in risk. This automatically, for me as a security analyst, makes me think that I should prioritize and probably investigate this session versus a session where only malware was found and that was the only activity that led to an increase in risk. So we're already taking the hundreds or thousands of AV alerts or security alerts and we're paring them down to potentially 8 sessions to investigate. Now, I can also take a look here and I can click on the alerts and I can see what type of security alert was triggered in this case. So for Barbara Salazar, I see that there was a Palo Alto next-gen firewall alert and related to large outbound traffic volumes. So if I'm a security analyst and I care more about malware, less about data exfiltration, I could come through here and start to look at the other alerts to identify something that may be of interest to me to investigate. Now, this is also great for if you have a malware team doing reverse engineering or threat hunting to come in here and identify those pieces of malware or strains that might be unique to the organization or something they want to spend a little more time investigating. So here for Keisha, I can actually see that there was a Cisco AMP alert, and this one is looking at Sality malware being detected. Now, this is a very broad way of looking at things. If I want to pare these results down even further, I can come and I can look at the specific activity types that also occurred. So maybe I want to look at where did I have malware or a security alert and database logins or queries being done. Or if I just look at the very bottom of this list, the rarest activity types, I can see that somebody had a piece of malware or a security alert when they were logged in on the VPN. And again, this could be more risky. If the user's credentials had just been compromised through Office 365 and now I have an attacker logging in on the VPN, they may be trying to install some malware to gain a foothold into the organization. I can simply go ahead and click on the VPN login. This is going to add that criteria to my threat hunt search results. And now I can filter in and see that this is Barbara Salazar. I can see already that she did VPN into the organization and had a security alert. Now, if I wanted to, at a high level, understand all the other activities that she performed that led to this 222 points of risk, I could go ahead and I could click on the risk reasons. And I can start to see all of the different anomalies and rules that Barbara triggered. And again, this can help me understand if I want to spend my time investigating this user. Does this look like something that I can't explain that's interesting to me? I can also take a look at all of the events that she performed. So I have a user who's VPNing into the organization with a security alert. I also can see that she performed an account switch and had some database activities within this particular session. Now, this is not the session we're going to investigate today, but this is probably something that I want to mark or flag and have somebody follow up and do an investigation on exactly what happened with Barbara. So this is one way to start very high level and use Threat Hunter and start to look at security alerts and then pare down from there. Now, the other way to do this is to understand what are the rare security alerts that have happened across my organization. Now, in most cases, you're looking at AV alerts either from the antivirus console or from something like your SIM. So you may have a dashboard or something that looks like this, that lists all of the AV detections. And a lot of times you're getting adware, potentially unwanted programs. You're getting the commodity malware, malvertising that's very common and cleaned up by AV. So what you want to focus on is the things that you've never seen before, unique signatures, unique detections, and malware that is new to the business. So with advanced analytics, we can actually help identify new malware and new strains of security alerts. And we do this by simply taking in all your alerts and modeling them to understand what's normal, what's rare. So once we have this capability of modeling, we can come in again and we can start another threat hunt search. I'm going to again expand this out to January. And now what we're going to do is we're going to come to the risk reasons. The risk reasons is the full list of all the anomaly detections we have out of the box. So I'm going to just come in here and type in security alert. And I can see here I have an anomaly for first security alert by name for the organization. So we parse out the signature as the name of the security alert. I'm going to go ahead and click on this and hit my search. Well, now already I took all 8 security alerts, and what you'll have is a lot more in the organization. I've pared this down to one user. So I can see that Frederick Weber has gotten a security alert that we've never seen across the entire organization before. Again, this is much more interesting than trying to follow up on every single piece of malware that's detected. Now, we're going to actually investigate Frederick to see exactly what happened. We want to understand where did the malware come from, what happened after, and potentially is there anyone else infected by this malware. Now, because it's the first time we've seen this in the organization, most likely Frederick's the only user. But that's not to say that there's not other strains of malware that Frederick could have downloaded that haven't been detected that maybe other users have seen. So we're going to drill into Frederick, but there's one other way that we can start to look at investigating malware. So we started very high level with security alerts. Now we're paring it down to looking at the first security alert for the organization by name. We can also be very specific. So if you're looking at the FireEye console, the EPO, a lot of security alerts have a unique identifier, a unique identifying ID. We can actually take that ID, and without even opening up Threat Hunter, just in our basic search bar, we can start to search for a security alert ID. So if I search for this security alert ID, it's going to tell me that, hey, Frederick Weber actually is the owner of this alert ID. It's going to tell me what session this was in, Sunday 7/1, the time of the session, what the detection is, it's FireEye, NanoCore, and the overall risk of this session. So again, if I wanted my analyst to come in here and validate whether or not they should spend time investigating a piece of malware, they can take the alert ID, pop it into the search bar, and if there's additional risk associated, something over maybe 20 points, that might tell my analyst I should investigate and take a closer look. I know it's not just the security alert in this session, some other things have happened that might warrant me to take a closer look. Now, what's unique about this particular alert ID, and FireEye alerts are very common for this, is when you get the alert, if you were to look at the raw logs, it's only going to include the source IP and the dest IP of the communication. It doesn't give me the host or the user. Now, what Exabeam's doing here is it's leveraging our host-to-IP mapping technology, where at any given time we're mapping what host has what IP in the environment. We take it a step further and understand then what users logged into that host. This allows us to essentially do username to IP address attribution on the fly. So if I have an alert that only includes an IP address, we can tie it to the user that was on that IP at that point in time, just like what we're doing for Frederick here. So if you have this problem in the environment where every time you get a FireEye alert or an alert that only includes a source IP address, and your analysts have to spend time first going through DHCP logs to find out the host name, and then through Windows logs to find out who was logged into that host, Exabeam can automatically save you a ton of time by plugging in this alert ID and understanding who's the user behind this alert. So what we're going to do is we're going to start to investigate Frederick from here. So the first thing I always do is I click on Frederick. I want to know who he is in the organization. What does his risk look like over time? So I can automatically see here Frederick Weber. His username is fweber. Right? This will also tell me any other credentials I've seen Frederick use. And again, this helps me scope my investigation. I'm investigating malware that Frederick's got. He's only ever used his fweber account. If he had a privileged account, if I've seen him use root or other credentials, I might want to increase the scope of my investigation. If he's got malware and it's stealing passwords or credentials here, it may have stolen additional privileged credentials. In this case, I'm guessing it's probably just tied to Frederick. I also know he's a web developer. And again, this helps me understand how risky is it for Frederick's credentials to be compromised. He may have access to development systems or areas of the business that aren't logged. A lot of times we see development servers and environments that don't have a whole lot of logging. So it's possible that he has development credentials we don't know about that the attacker could gain access to and exfiltrate source code or sensitive information. So understanding this context is all about helping to understand the risk of this user being infected by malware and his credentials being stolen. Stealing credentials is the most common thing that malware wants to do. right? Second is to gain that foothold in the organization. But that malware wants to start to harvest credentials to move laterally and access the crown jewels across the business. We can also see things like when he was first seen on the network, when he was last seen. Again, this helps me understand, was this a dormant account that's just popped up? He's a new user? Here we can see he's been around for a while. We also know his manager and his peer groups. So I can see he's part of the web developer peer group. Again, I can open this up and I can start to look at other attributes, like who are all the other web developers? And is this maybe a targeted, a spear phishing campaign? Do I have other web developers who are now getting increased risks? Maybe a bunch of the web developers were hit with a phishing email, they all clicked on it, and they all got the same malware installed on their machine. But I can see here, as I look, only Frederick here has any sort of risk in his latest session. Everybody else has 0 points of risk. So to me, this doesn't look like a spear phishing campaign. It was something very targeted, or it was maybe something Frederick got downloaded when he was browsing the web. Next, we can take a look at his risk timeline. So this is a really key component of the analytics. We know that breaches don't last hours or days. They last weeks, months. And so this gives me the ability to pan out and look very wide at what is Frederick's risk across time. What has he been up to? And here I can see that he's not a user that exhibits a lot of anomalies or has a lot of risk. So this seems to be kind of a one-off malware incident. It's not like Frederick last week had some risk scores, or 2 months ago he had more malware and we see abnormal account creation and things in between. Looks like this is just kind of a point in time. But this allows me to look really quickly at what happened over the last 3 months, where I don't have to run a long query and wait for those results. Typically, when we're investigating malware and users, we're only limiting ourselves to 24, maybe 48 hours, sometimes a week, just because of the sheer volume of events that are returned out of the SIM or your data lake. Here, we don't have that problem because the analytics has already boiled down and condensed all of the information. So what I'm going to do is I'm going to go ahead now and we're going to take a look at this session where this risky activity occurred. So I'm going to go ahead and go to timeline. Now, what we see here is the first thing that happened is at 8:10 a.m., Frederick does a Kerberos login to his workstation. This is Frederick coming into the office and logging into, well, at least what looks like his workstation. It has fweber in it, which matches his username. I can verify this by clicking on the asset itself, and I can see he is indeed the top user, and he's actually the only user who's ever accessed this particular machine. So nothing particularly anomalous or malicious here. He's just coming into the office and logging in. We can see 2 remote access events, some web activity. Again, no anomalies detected or risk points added here, which means this is all of Frederick's normal behavior and normal activities. We can go ahead and expand the web activities here to see what he's accessing. He's just updates.microsoft.com in this situation. We scroll down a little bit further after he accesses LinkedIn and an app server. Then we see this access to zoomer.ru. And Exabeam is able to tell me that, hey, now he's accessing a domain which we've identified as DGA, or Domain Generation Algorithm. So this is the machine learning algorithm that Exabeam's built in-house. And this allows us to identify potentially suspicious or risky domains without needing threat intelligence. Threat intelligence often becomes stale very quickly. So this is our ability to look at the naming convention or the URL and identify if it looks like it's randomly generated. And here it does, and it scores with 10 points of risk. We're also seeing that this is the first time he's accessed a low-ranked domain. We consider anything outside of the Alexa top 1 million as a low-ranked domain. So he accesses what looks like this suspicious website. We scroll down a little bit further, some more normal behaviors, and then here is that FireEye alert. If I expand this here, I can see that security alert ID. Again, that's what matched up top that we searched on. It's saying that this is a FireEye Nano Core detection. Now, this is the first time, or this is the FireEye alert here on his workstation. We score this with 20 points of risk. Now, what's interesting here is I can see what workstation this is being installed on or detected on, and it's his workstation, Frederick's. This also helps me understand that Frederick is probably patient 0 for this piece of malware, right? He's installed this, or it's been installed on his workstation. Versus if I saw Frederick getting these AV detections using his credential on something like my domain controller or my app server, that might be more suspect than the fact that Frederick got malware on his own machine. Now, it's not to say this isn't interesting or it's not suspect, because it's also the first security alert with Nano Core across the organization. I've never seen this particular signature trigger across my organization. Again, I can click on the Nano Core and I can say, well, what are the typical AV signatures that we see? A lot of it's adware. We see some coin miners, which are pretty popular nowadays, and a bunch of other variants. But we've never seen Nano Core. Now, after we see FireEye detect this and clean this particular piece of malware, we see some more normal behavior for Frederick. And we keep scrolling down, And then toward the end of his day, we also see him accessing another domain. And again, this is another low-ranked domain, which scores 10 points. And it's also a domain that's in the Ukraine. We've never seen Frederick communicate via the proxy to any domains in the Ukraine. Again, I can go ahead and open this up and show you all the domains and countries that he typically accesses. Now again, what's important here to understand is that just because FireEye detected some of the malware doesn't mean that it detected all of it. A lot of times malware will download additional strains of malware. And here, this is probably most likely the case. Yes, the AV caught it and removed it, but there's still a risk to the business because it's still communicating to low-ranked domains. Again, this is why we can't just take AV at face value. We should be spending more time doing deeper investigations to understand what is this malware doing in my organization. Now, in the case of Frederick here, this is really all we're seeing in his sessions. He hit a DGA, FireEye alerted to us, and he still got some abnormal communications. So what we may want to do now is add Frederick to a watch list. We may want to keep a closer eye on this credential to see does it continue to act anomalous while we're doing additional investigations. So I can come back to my home screen here, and I have a watch list called users infected with malware. So I'm simply going to come in here, Weber, and I'm going to add Frederick to my watch list. Now this is going to allow me to see any fluctuations in risk. I don't need to wait for him to become notable in 90 points. If tomorrow now he scores an additional 75 points of risk, I can see what he's been up to. This also lets me know, and I can start to think about what else would help me understand more about Frederick and his malware infection. Right? This can help me think about what other log sources would it be valuable to bring into the analytics to paint me a more detailed picture. Right? I still don't really know why Frederick went to this domain. So bringing in something like email logs might give me additional details on the fact that he received an email from a new domain or a new geolocation that had a link, and maybe he was phished into clicking that particular URL, and that's why he hit this DGA. I also don't know anything really about what ran on the endpoint. So I may want to look at bringing in process execution logs into analytics to provide me more details of what happened on the endpoint when this attack occurred. These are the kinds of logs that can give me more detail about what's going on within my environment. I also may want to think about looking at Exabeam's entity analytics, where we can take a look at the host perspective. What happened from Frederick's asset? Where did it communicate to? Any abnormal ports? Did it start to exfiltrate data? Can we look at how normal the amount of traffic was? Right? These are all things we can start to look at to provide more visibility and answer some of these additional questions we might have. Now, I chose Frederick in these logs because most of our customers have the proxy logs, antivirus, and Windows coming in. But this is a great starting point that can then jumpstart you into thinking about what other logs will provide additional visibility to help you close out this investigation much faster. We could also look at leveraging Exabeam's incident responder, right? Creating an incident out of this particular notable session or this session itself, and generating an automatic playbook to grab that malware off the endpoint or to quarantine this machine and take additional actions. Now, I do want to look at what this may look like when I have a user that has more logs. So we're going to look at S. Lee, Sherry Lee. And she has more logs in her timeline around process execution and file activities. So we're going to jump into her particular timeline. And I can see for Sherry Lee here, we see her executing Chrome and Facebook. Then I see her receive an email from KLEnergy.com. This is the first time it's abnormal for an email from KLEnergy.com across the organization. So we've seen this before, but only once. So it's a rare domain to send to the organization. It's also the first email to or from KL Energy for Sherry, and it's an abnormal domain for her particular peer group. Now, after she receives this email, now we see her go ahead and access file mirrors. And again, this is another DGA, right? It's a low-ranked domain. So now we start to better understand why is Sherry hitting this DGA. It's probably due to this potential risky or suspicious email that she received. We also start to see things like process execution occurring. She's starting to execute processes for the first time, right? So now we can see potentially malware infections happening and processes running even if there is no malware detection. So in the case of Frederick with Nanocore, it looks like he's still infected with something. If we were able to see the processes that were running and we could see that, hey, this is the first time this process is run, we might know what else is running on that endpoint that's leading to these suspicious communications. We can see here file writes that are occurring for Sherry, Tor.exe. And in this case, what you're going to see is Sherry's actually infected with ransomware. So after Tor.exe runs, we start to see Sherry accessing a lot of files, right? So she's going to start to read all the files on the endpoint. It's going to start to encrypt them and delete them after. This is what we're seeing here. But this is the ability now to think about what other logs can I provide the analytics to provide me that richer visibility and context about what's really going on the endpoint. Now, the other thing we can do is both Sherry and Frederick were hit with malware from a DGA. Now, a DGA is typically going to be randomly generated, and so it's not easy for me to take that domain and search it within my SIM or within Exabeam and identify who else accessed that domain, because they may have only accessed that unique domain once. So what we can do is we can use the behavioral search capabilities of Threat Hunter to identify any other users who have accessed DGAs. Right? So this may help me understand who else across the organization may be infected with similar malware or is being hit with a similar campaign. So again, we're going to come back into my Exabeam Threat Hunter, and I'm going to search just the last 90 days. We're going to search for DGA. First access to this domain, which is identified as DGA. And we're going to go ahead and search that. And I can see if I only look the last 30 days, Frederick is the only user who has this particular detection. Now, Sherry Lee's detection happened longer than 90 days ago, which is why she's not showing up. But this at least helps me understand that there isn't a large malware campaign against my organization where I have a lot of users accessing DGA who may also be installed, have NanoCore installed, or some other piece of malware. It looks like it's pretty contained to just Frederick. Now that we're done with our security investigation on Frederick, I wanted to take a little bit of time to also talk more in depth about the host-to-IP mapping technology that Exabeam has. Now, this technology really underlies and pins the session data model that we build, and it's unique to Exabeam. But we can also use this to start to understand at any point in time. I can take an IP, a host name, and understand the inverse. I don't have to go to my DHCP logs and piece these together. This was a common problem that I had when I used to work with a lot of SOC analysts in the SOC. Is we would have a user on their mobile device and they'd move around the corporate campus on Wi-Fi and they'd have 10 different IPs throughout the day. When we were investigating what that user did, we had to figure out at any point in time what was their IP, how long did that lease duration occur, and we'd have to do individual searches across those timeframes to understand what a user did in a complete day. Now, Exabeam and our sessions are doing this automatically for every user. But let's highlight this and take a look. I can go ahead and I can search for an IP address here in our top search bar. And once I have the complete IP typed in here, we can see, what host has this IP currently. And I see no host name assigned to this, which means that it's currently an open IP. But below, I can look at all assets that were associated with this IP over time. And I could go ahead and click View Asset Associations. And here we can actually take this and we could drill into a specific time frame. I can say, show me all of the assets that had this IP over a 2-week time frame. So if I'm investigating a specific IP address that's making outbound connections, I can find what host had that IP and when. I can also get information about the host name. I can see what user is the top user of that host, right? So this is going to tell me most likely which user was logged into that host when it was doing specific activities or had this lease of this IP address. And we'll give you the full lease assignment here. Right? So this is our ability to really quickly take any IP across the organization and tell you every single machine that had it and when. Now we could also drill in and start to look at Threat Hunter and view these sessions within a threat hunt. I can also take the inverse. So I know this is IT G Harden 888's machine. I could go ahead and close this, and I can go ahead and search this particular machine. And again, I'm going to see what IP it currently has. It ends in 109. I can go ahead now and look at from the entity's perspective. Right? I can see the host, and I can come down to the IP address, and I can look from the host perspective, what are all of the IP addresses that this host has had. And here I can see every single IP and the lease of that particular IP. Now this is that ability now really quickly. I don't have to go to my DHCP logs and search. I can use Exabeam's analytics. But remember, I don't have to do this every time I'm investigating a user. Our sessions are already doing this automatically to build out and understand when users change IPs and devices across the network. So please use this. It's a huge time saver for most of our customers and our security analysts to be able to really quickly understand a host or an IP or the inverse. So now we should have a better understanding of how we can leverage Exabeam's advanced analytics, not just to investigate the notable users that are popping up daily, but to also leverage Exabeam's analytics to help understand malware. What is unique malware to the business? What is malware doing? Where did it come from? What does it do after? This is our ability to fit into your day-to-day incident response process to give you better risk coverage and understand the risk to the business of all of the malware that's being detected. So thank you for watching. My name's Andy Scree.